Okay, in this video we're going to talk a little bit about how objects become charged. We've talked a little bit about charge, but not exactly how objects develop a charge. So there's two main mechanisms by which this occurs. One is through conduction, which is actually charged by contact, physical contact between objects. The second is called induction, and that is where charge is induced, but it's really a result of separation of charge after physical separation of charge after charges are distributed in some way. So we'll start by talking about conduction, which occurs differently in the two different kinds of materials we talked about, insulators and conductors. So we'll start with talking about insulators, which, as you remember, are sort of objects that have electrons that can't move very far from their nuclei. So if we bring a big positively charged rod over towards an insulating object, and we physically touch that rod onto that object, we'll have a charge transfer that occurs through contact. Now, when we remove the rod, the charge that is placed on that object remains pretty darn close to where it was placed. And the reason for that is because those electrons are tied very strongly to their positive nuclei, so charge is not able to move around very easily in an insulator. In a conductor, we can bring up this positively charged rod again, and we have our sort of neutral conductor here, and we touch them together, and a charge transfer occurs once again. But this time, because the object is a metal or a conductor, those electrons can move around pretty easily, they can redistribute, and thus charge can move around pretty easily once we separate the two objects, and they disperse to be very far apart from each other. Now, how they actually distribute depends on how much charge is transferred and precisely the shape of the object and so forth, but it sort of pushes as far away from other charges as possible. Now, in terms of the other mechanism by which we can charge objects, induction, this most commonly occurs in metals. And you'll see why. It involves charges being able to move pretty far distances. So we're going to focus on metals and conductors for induction. And the idea behind that is that we start off with some object that has charge, let's say this positively charged rod again, and very far away from it are two metallic objects that are in contact. We bring these two objects close to this charged object, and because they're metals, because they're conductors, the electrons can move around very easily, and so the electrons tend to migrate over here closer to the positively charged object, leaving behind positively charged atomic cores. Now what we do is physically separate the two metal objects in the presence of the third object. But notice we never touch this bar to these two spheres. And so now we end up with a metal ball that has a negative charge, a net negative charge, and a metal ball that has a net positive charge. If we remove then the rod, pull it really, really far away, take the two spheres over here, these will redistribute as well in some way, again depending on their shape and how much charge gets transferred. But what we end up with is a net negatively charged and a net positively charged object, whereas before we had two neutral objects. So this is the example of induction. So what you've seen here is three different ways in which we can charge objects: two by contact for insulators and conductors, and one which is by induction for conductors.